This is chapter 11.1 from Stewart's Calculus, Early Transcendentals. My intention is to go over the highlights of each chapter for my students in Math 222. So this is the introductory overview chapter, and on the left-hand side I have the what side, and the right-hand side I have the why side. So what we're learning in 11.1 is about sequences. Those are just a set of numbers. So I think of it as apartments, with each apartment has contents, which is a different number. And this little n down here, this is the house number. And there's lots of ways of writing sequences, but that's the main point. Okay, in 11.2 we're talking about series, where we're adding things together. And in 11.3, 4, 5, 6, 7, it's all about rules for convergence. So we have to talk about what makes things converge or not. And then in 11.8 and 9, we're talking about power series expansions of a function. In other words, we're going to use a polynomial to approximate, let's say, sine or cosine. And then 11.10, well, actually 11.10, we're going to essentially use polynomials to express, other functions. So 11.8, 9, and 10 are all tied together. So that's what's going on. So a sequence is a list of numbers, and you can just list them with commas in between. And if the progression of the sequence is obvious, you can just use ellipses. That's just 3 little dots here. That's what that means. Or you can put curly brackets and then write the formula in terms of n. And some conventions start the first term at n equals 0. Some start at n equals 1. You can specify this. F of x is very much like f of n. The only difference is these guys are discrete. These guys are continuous. Okay, so other than that, they pretty much work the same way. You can use calculus on them. Right, so if you think of f of x as the function that's continuous, and then the fn's are just going to look like little points stuck on the function. So some examples. For example, what about the sequence 2n over n squared plus 1? So if you look at what's going on here, I just had 1, so 2 over 2 becomes 1. But the rest of them I just didn't do any simplification. So the numerator is just even numbers, and the denominator is 1 more than a perfect square. Okay? So this is strictly decreasing, and you can just use calculus on the function 2n over n squared plus 1 and just see that it's strictly decreasing after a certain point, that being, well, we're starting our sequence at 1 here. It's going to strictly decrease down to 0. Sequences don't have to have an explicit formula. They can just be a list of numbers. And I had you guys try some of these in class. This is towards the end of class one day. And what we found out is, sine of 0 is 0, 0, 0. All these guys are zeros. Very boring. Cosine, however, is not boring. If you start with 0, then you're going to go 1, minus 1, 1, minus 1, 1, minus 1. And this is often used in place of minus 1 to the power of n in order to get something to toggle. And let's see, this formula, see, it really depends if you start at n as 0 or if you start at n as 1. So for n is equal to 1 and forward, this would mean starting with a positive sign on n equals 1. So it would be 3/5. And then the next term, they're going to just alternate signs, and the denominator is going to hike up power of 5, and the numerator is just going to add 2 more. So even though obviously 5 over 5 squared simplifies to 1 over 5, there's no point in simplifying it, because then you would lose the progression. Okay, so that's what that one looks like. Not very exciting. And then we talked about recursive definitions, and we actually spent a really long time talking about that. The part that you need to take away is you need to know the difference between recursive versus explicit. Okay, so you have to understand that this is what a recursive formula looks like, and what this means is this is always, either way, this is on the left hand side. The question is what's on the right hand side. Is it just n, or is it previous fn's like that? If it's just n's and in numbers and things, this would be explicit, but if it's got these guys in it, then it would be implicit. Okay, I think this is probably a good place to break this video.